Hello, everyone. Thanks for joining me. Before we get started, a few words about the conference, this is the first time I'm at DDD, and I totally feel like I missed something before that. It seems to be like an amazing group of people, and so far, so great. So I'd like to talk about a few things and mention them about the conference. So there's a code of conduct. I don't know if you noticed it, but generally the gist of it is be nice to people, so which I think should work out pretty nicely. Also, several organizations wanted to sponsor DDD, even though there's no cost to cover. So everything's going to the National Museum of Computing. Again, a great cause and also great in terms of the conference. And these are the sponsors who help the National Museum of Computing. So check out their products and send positive feelings towards them is the general thing I'm saying here. So also, if you're tweeting about this talk, about other talks, about the conference in general, be sure to use hashtag DDD 2021 and tag at Developer Day. Again, that's for Twitter. Do other things for other social networks if you think so. That's appropriate, and obviously that's appreciated. So without further ado, let's get on with the actual presentation. So today we're going to talk about Polyglot Cloud Native debugging and a bit about APMs. But first, a few things about me. I was a consultant for over a decade. I worked at Sun, founded a couple of companies, wrote a couple of books. I wrote a lot of open source code. I currently work as a developer advocate for Lightrun. My email and Twitter accounts are listed here, so feel free to write to me. I have a blog that talks about debugging and production issues at talktotheduck.dev. It would be great if you check it out and let me know what you think. So I love APMs. They're wonderful. They're absolutely wonderful. I'm old enough to remember a time where they weren't around, and I'm just so happy we moved past that. This is truly amazing. The dashboards and the details you get this dashboard with just everything you need. It's amazing. We're truly at a golden age of monitoring. Hell, when I started, we used to monitor the server by kicking it and listening to see if the hard drive was spinning properly. Today with Kubernetes, the deployment scaled to such a level that we need tools like this to get some insight into your production. Without APM, we're, well, blind as a bat isn't the word I'd use, although it actually fits really well with the rest of the presentation, as you'll see soon enough. But it's pretty close. You're missing a great deal of information. So a lot of issues we run into start when we notice an anomaly in the dashboard, when we see a spike in failures or something that performs a bit too slow. The APM is amazing in showing those hiccups. But this is where it stops. It can tell us that a web service performed badly or failed. It can't tell us why it performed badly or failed. It can't point at a line of code. So let's stop for a second and talk about a different line. This line. On the one side, we have developers. On the other side, we have the ops or DevOps. This is the line that we've had for a long time. It's something we drew out of necessity because when developers were given access to production, well, I don't want to be too dramatic, but when developers got access to production, it didn't end well. This was literally the situation not too long ago. Yes, we had sysadmins, but the whole process used to be a mess. That was no good. We need a better solution than this hard separation because the ops guys don't necessarily know how to solve the problems made by the developers. They know how to solve ops problems. So when a container has a problem and the DevOps don't know how to fix it, well, it starts a problematic feedback loop of test, redeploy, rinse, repeat. That isn't ideal. Monitoring tools are kind of like the bat signal. They come up and we, the developers, we're Batman or Batwoman or Batperson. All of us, heroes, yeah, at least in those cases. We step up to deal with the bugs and we're the last line of defense against their villainy. Well, we're closer to bat coder people. Kind of the same thing without the six-pack abs, too much baked goods in the kitchen here for, all those startups and companies. Coder Batman kind of needs to know where the crime or bugs are happening in the code. So these dashboards, they point us towards the crime we have to fight in our system. But here's where things get hard. We start digging into logs, trying to find the problem. The dashboard sent us in a general direction like performance problem or high error rates. But now we need to jump into the logs and hope that we can find something there that will somehow explain the problem we're seeing. That's like going from this jet engine back to Stone Age tools. There are many log processing platforms that do an amazing job at processing these logs and finding the gold within them. But even then, it's a needle in a haystack. That's the good outcome, where a log is already there waiting for us. But obviously we can't have logging all over the place. Our billing will go through the roof and our performance will suffer. So we're stuck in this loop of add a new log, go through CI/CD, which includes the QA cycle and everything. This can take hours. Then we produce the issue in the production server with your fingers crossed and hope that it will happen again. And then try to analyze what went on. Hopefully you found the issue, because if not, it's effectively rinse repeat for the whole process. In the meantime, you still have a bug in production and developers are literally wasting their time. There just has to be a better way. It's 2021 and logs are the way we solve bugs in this day and age. I mean, don't get me wrong. I love logs and today's logs are totally different from what we had even 10 years ago. But you need to know about your problem in advance for a log to work. The problem is I'm not clairvoyant. When I write code, I can't tell what bugs or problems the code will have before the code is actually written. I'm on the same boat as you are. The bug doesn't exist yet. So I'm faced with the dilemma of whether to log something. This is a bit kind of like the dilemma of writing comments. Does it make the code look noisy and stupid, or will I find this useful at 2 a.m. when everything isn't working and I want to rip out a few strands of hair I have left because this damn production problem? So debuggers are amazing. I love debuggers. My blog is about debuggers and debugging and how debugging is great. They're the best thing, well, I'd say since sliced bread, but kind of a different apples oranges comparison. They're great. They let us set breakpoints, see call stacks, inspect variables, and more. If only we could do the same thing for production systems. But debuggers weren't designed for this. They're very insecure when debugging remotely. They can block your server while sending debug commands remotely. A small mistake, such as an expensive condition, can literally destroy your server. I might be repeating an urban legend here, but 20 or so years ago, I heard a story about a guy who was debugging a railed system located on a cliff. He stopped at a breakpoint during debugging, and the multi-million-dollar hardware fell into the sea because it didn't receive the stop command. Again, I don't know if it's a true story, but it's plausible. Debuggers weren't really designed for these situations. Worse, debuggers are limited to one server. If you have a cluster with multiple machines, the problem can manifest on one machine always, or might manifest on a random machine. We can't rely on pure luck. if I have multiple servers with multiple languages, platforms crossing from one to another with the debugger, well, it's possible in theory, but I can't even imagine it in reality. I also want to revisit this slide because I do love having APMs, and looking at their dashboard does give me that type of joy we get from seeing the results of my work plotted out as a graph. I feel there should be a German word to describe that sort of enjoyment. But here's the thing, APMs aren't one thing. The more you instrument, the more you have runtime overhead. The more you have runtime overhead, the more hosts you need to handle the same amount of tasks. The more hosts you have, the more problems you have, and they become more complex. I feel Schrödinger should probably deliver the next line. By observing, we effectively change some of the outcome. So an APM needs to observe everything. An APM doesn't know what it's looking for. Like I said before, it's a bat signal or a check engine light. It's got sensors all over the place, and it needs to receive information from these sensors. Some sensors have almost no overhead, but some can impact the observed application noticeably. Some people use that as an excuse to avoid APMs, which I feel is like throwing away the baby with the bathwater. We need APMs. We can't manage at scale without them, but we need to tune them, and observing everything isn't an option. Thankfully, pretty much every APM vendor knows that, and they all let us tune the ratio of observability to performance so we can get good results. Unfortunately, that means we get less data. Couple that with the reduction of logs that we need to do for the same reason, and the bad problems we have in production just got a whole lot worse. So I want to take the Batman metaphor all the way here. We need a team up. We need some help on the servers, especially in the clustered Polyglot environment, where the issue can appear on one container, move to the next, etc. So remember this slide. We need some way to get through that line, not to remove it. We like that line. It's a good line. We need a way to connect with the server and debug it. Now, I'm a developer, so I try to stay away from management buzzwords like the word for this is shift left. It essentially means we're letting the developers and QA get back some of the access we used to have into the ops. So in this case, this is a very apt management word, because without demolishing the gains we had in security and stability, we need to get some of that access. We love the ops people and we need them. So this is about helping them keep everything running smoothly in production without stepping on their toes or blowing up their deployment. So this leads us here. What if you could connect your server to a debugger agent that would make sure you don't overload the server and don't make mistakes like setting breakpoints or something like that? That's what continuous observability does. Continuous observability is complementary to the APM. It works very differently. Before we go on, I'd like to explain what's continuous observability. Observability is defined as the ability to understand how your systems work on the inside without shipping new code. The without shipping new code portion, that's key. But what's continuous observability? With continuous observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving the information. With continuous observability, we flip that. We ask questions and then instrument based on the questions. So how does that work in practice? Each tool in the field is different. I'll explain the Lightran architecture since that's what I'm familiar with. And I'll try to qualify where it's different from other tools. In Lightran, we use a native IDE plugin to VS Code or JetBrains IDEs such as IntelliJ, PyCharm, WebStorm, etc. We can also use a command line tool Other tools sometimes have a web interface or CLI only. This client lets us interact with the Lightrun server. This is an important piece of the architecture that hides the actual production environment. Developers don't get access to the production area, which is still the purview of DevOps. We can insert an action, which can be a log or a snapshot or a measurement metric. I'll show you all of these soon enough. This talk will get into the code portions soon. Notice that the Lightrun server can be installed in the cloud as a SaaS or on-premise and managed by ops. The management server sends everything to the agent, which is installed on your production or staging servers. This is pretty standard for all continuous observability solutions. I don't know how other solutions work, but I assume they are pretty similar. This means there's clear separation between the developer and production. As you can see, the DevOps still has the guarding line we're talking about. They need to connect the agent to the management server, and that's where their job ends. Developers don't have direct access to production, only through the management server. That means no danger to the running production servers from a careless developer, well, like yours truly. The agent is just a small runtime you can add to your production or staging server. It's very low overhead and it implements the debugging logic. Finally, everything is piped through the server back to your IDE directly. So as a developer, you can keep working in the IDE without leaving your comfort zone. So, okay, that should raise the vendor alert here. I heard that bullshit line before, right? APMs have been around forever and have been optimized. How can a new tool claim to have lower overhead than an established and proven solution? As I said before, APMs look at everything. A continuous observability tool is surgical. That means that when an APM raises an interesting issue, we can then look at the specific thing like a line of code. When a continuous observability solution isn't running, its overhead is almost nothing. It literally does nothing other than check whether we need it. It doesn't report anything, and when it's practically idle. When we do need it, we need more data than the APM does. But we get it from one specific area of the code. So there's an overhead, but because it only impacts one area of the code, it's tiny. This is the obvious question. What if I look at the code that gets invoked a lot? As I said, continuous observability gets even more data than an APM does. This can bring down a system as well. We could end up here. So this is where continuous observability tools differ. Some tools provide the ability to throttle expensive actions and only show you some of the information. This isn't a big deal. This is a big deal in high volume requests. I think these things are best shown in a demo because I can talk your ears off, but showing a quick demo can explain this faster. I'll use Kotlin for this demo, but this applies to other languages. In this demo, I'll skip the setup portion, but I'll get back to this with the next demo. So this is the prime main app in Kotlin. It simply loops over numbers and checks if they are prime numbers. It sleeps for 10 milliseconds, so it won't completely demolish the CPU. But other than that, it's pretty simple, a pretty simple application. It just counts the number of primes it finds along the way and prints the results at the end. We use this code a lot when debugging, since it's CPU intensive and yet very simple. In this case, we would like to observe the variable I, which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. The simplest tool we have is the ability to inject a log into the application. We can also inject a snapshot or add metrics. I'll discuss all of these soon enough. Selecting log opens up the UI to enter a new log. I can write more than just text in the curly braces. I can include any expression I want, such as the value of the variable that I included in this expression. I can also invoke methods and do all sorts of things. But here's the thing. If I invoke a method that's too computationally intensive, or if I invoke a method that changes the application state, the log won't be added. I'll get an error. After clicking OK, we see the log appearing above the line in the IDE. Notice that this behavior is specific to IntelliJ or JetBrains IDEs. In Visual Studio Code, it will show as a marker on the side. Once the log is hit, we'll see logs appear in batches. Notice I chose to pipe logs into the IDE for convenience, but there's a lot more I can do with them. For now, the thing I want to focus on is the last line. Notice that the log point is paused due to high call rate. This means additional logs won't show for a short while since logging exceeded a threshold of CPU usage. This can happen quickly or slowly depending on how you're observing. That's a relatively simple demo to whet your appetite. Let's pull out the big demo guns. So I decided to take on Netflix and build my own movie service. Seems easy enough. Turns out it isn't so much, and those people at Netflix sure know how to build applications. This is rough. I'm terrible at front end, so I hired a developer to build it in React. He also built a Node.js server, which was pretty intuitive for a front-end person. This is actually a pretty sensible architecture. It lets the front-end developers handle all their stuff, including the start of the back-end area. Node.js scales reasonably well and can handle the stuff it's good at, communicating with the UI front-end, etc. Node.js also scales reasonably well, so we've got a pretty good deal overall. Storage, transactions, and reliability are decades ahead in the world of Java. So using Spring Boot for the backend heavy lifting also makes sense. I know it and built a lot of stuff with it. This is a merge of the best of each world has to offer. It also lets us hire the right people for the right job. The problem starts when we need to debug this, especially in production. Finding the source of the bug is a process of digging through logs with different conventions and sometimes even different terms for the same thing. And the problem is we have bugs. So here's the app that will take over the world. As you can see, I have a list of movies in the UI that reminds us a bit of those big guys who, again, are doing a pretty spectacular job here. I can add a movie to my list. I can visit my list and see the movies within it. I can open a specific movie and see details about it. Well, that's pretty much it. So here we can see Clifford, and we can look through other movies like James Bond, for instance. But here's the weird thing. When I click the No Time to Die movie, there's a problem. I get red notice instead. It's a weird bug, and I have no idea why it would happen. I think we can debug it using continuous observability. So first, we need to sign up on Lightrun to debug it with the Lightrun tool for continuous observability. And we can then set up the agent and ID plugin, which will let us debug this application. I won't go into the details of installing IDE plugins. The agent is the more interesting part. I'll start with the Java agent, since we'll be running the Spring Boot server first. To install the agent, we need to set up an agent directory. This is done using this bash command. On Windows and Linux, there are similar commands. Notice that normally the agent will run on your server, so you need to download the version matching your operating system from the server, which is in my case, in the production, if it's Linux, I might need to select Linux instead of selecting the default, which is a Mac OS, because I'm using a Mac for this presentation. The next step is adding the argument to the execution process of your app. This gives the agent access to the internal instrumentation tools it needs. In this case, it mapped to this relatively simple command line. So far, so good. The Node.js version is, in some regards, even simpler. We just use npm install lightrun and then add this small snippet to the top of your application. Once this is done, both nodes, the Node server and the Spring Boot server, are ready for business. This is the Node.js project that implements the initial backend of our architecture. This is the method that gets invoked when we click a movie and want to see the details. This time, I'll add a snapshot. Some other continuous observability tools call this capture or non-breaking breakpoint, which to me sounds weird, but the idea is usually the same. Once I press OK, the camera button appears on the left, indicating the location of the snapshot, like you would see with the regular ID breakpoint. Now, let's go back to the browser for a second. And we wait a few seconds for the problem to reproduce. Now, we need to go back to the IDE. And now we wait a second, and the snapshot is hit. So what is this snapshot? It gives us a stack trace and variables, just like a regular breakpoint. We all know and love, but it doesn't stop at that point. So your server won't be stuck waiting for a step over. Now, obviously, you can't step over the code, so you need to step by individual snapshots. But this has huge benefits, especially in production scenarios. So what do we see here? We see the ID of the movie, and it seems to be the right ID. So this isn't a case of bad ID passing from the UI. And we need to dig deeper into the Spring Boot server. In the Spring Boot server code, we've got the fetch movie details method, which does the actual fetching. I place a snapshot here, and I'll spare you the pain of going to the web every time I have a curl command that performs the request. So I'm running it in a different window here, as it's not really interesting. So now we need to wait for the snapshot to get hit. If this seems to take too long, spoiler, it never gets hit. And the reason for that is the cacheable annotation you see above the method. It seems the response from the method is cached. Unfortunately, we can't rely on guesses. We need to verify. So we need to go to the movie manager, which is our REST controller. It handles all the web requests directly. So here we can add another snapshot and again try to trigger the curl script with the hope that this time we'll get it right and the snapshot will get hit. After a bit of waiting, we finally hit the snapshot in the get method. This means our request is happening, but the failure we're seeing is because the cache got corrupted with bad data. Why would that happen? And can we continue our investigation? Well, yes, we can. The place where the cache might be corrupted is here. In checks for file updates, this method runs periodically every 60 seconds and checks the file system for an import file. This is a pretty common feature in applications where you place a file in the file system and background process loads that file and imports new data into the database or refreshes the database. So this is how we add new movies into the system. We place a file with the data and it might break the existing movies. So let's create a snapshot here, and while we wait for a minute for the snapshot to hit, we can use the time productively to delete the no longer used snapshots from before. They will eventually expire, but they're left here in case you need reference. Right now, they're mostly noisy, and you might be confused with them and the new snapshot that we have coming up. One of the nice things about debugging with snapshots is that normally you don't have to wait. You can just place them all over the code and they get hit at some point. So you can literally go to bed and the next day you have a snapshot. Great, snapshot got hit just in time. So that means this code is working. Now all I need to do is evict the cache with a dummy file and we're done. Or are we? Notice the methods here. The batch update evicts the cache. Or so it would seem. If you're new to Spring, I will do that and check for a bug again. We'll see the cache. If I do that and we'll check for the bug again, then we'll see that the cache wasn't evicted. The reason for this is that Spring only reads annotations when they're invoked from a different class by default. This is one of those gotchas that often fail developers new to Spring. I can't believe I fell for that. Ha! Yeah, my acting isn't great. So this was relatively simple in terms of observability. Let's up the ante a bit and talk about a user-specific problem. So here I have a problem with the trending request. One specific user is complaining that the trending list on his machine doesn't match the trending list for his peers. The problem is that if I put a snapshot, I'll get a lot of noise because there are many users reloading all the time. So a solution is to use a conditional snapshot, just like you can with a regular debugger. Notice that you can define a condition for a log and for a metrics as well. This is one of the key features of continuous observability. I add a new snapshot, and in it I have an option to define quite a lot of things. I won't even discuss the advanced options of this dialog in this session. This is a really trivial condition. We already have a simple security utility class that I can use to query the current user ID. So I just make use of that and compare the response to the ID of the user that's experiencing a problem. Notice I used the fully qualified name of the class. I could have just written security and it's very possible it would have worked, but it isn't guaranteed. Names can clash on the agent, and the agent side isn't aware of all the things we have in the IDE. As such, it's often good practice to be more specific. After pressing OK, we see a special version of the snapshot icon with a question mark on it. This indicates that this action has a condition on it. Now, it's just a waiting game for the user to hit that snapshot. This is the point where normally you can go to make yourself a cup of coffee, even if you go home, and check this out the next day. That's the beauty of this sort of instrumentation. So I made tea, and just for this specific slide, I'm going to oh, that's lovely. Going to enjoy that, and I really needed that with a coffee earlier on. So in this case, I won't make you wait long. The snapshot gets hit by the right user despite other users coming in. This specific request is from the right user ID. We can now review the stack information, and the next thing I want to talk about is metrics. The APM gives us a large-scale performance of information, and they don't tell us fine-grained details. Here we can count the number of times a line of code was reached using a counter. We can even use a condition to qualify that. So we can do something like count the number of times a specific user reached that line of code. We also have a method duration, which tells us how long a method took to execute. We can even measure the time it takes to perform a code block using a tick-tock. That lets us narrow down the performance impact of a larger method to a specific problematic segment. In this case, I'll just use the method duration. So measurements typically have a name under which we can pipe them or log them. So I'll just give this method duration a clear name. In this case, I'm just printing out to the console, but all of these measurements can be piped to statsd and Prometheus. I'm a pretty awful DevOps, so I really don't want to demo that in this case, but it does work if you know how to use these tools. As you can see, the duration information is now piped into the logs and provides us some information on the current performance of this method. It's really hard to show real-world scenarios here to explain observability tools properly, especially tools like this. Besides the IP problems, even if I was able to show one of our customers' systems, it's just too complex for someone to pick up in a talk. So I'm going to do something a little bit different. I'm going to demonstrate Airflow. Airflow lets you write workflows with Python and execute them at scale. There are many frameworks with similar concepts, such as Spark, etc. Lots of them have different use cases and target demographics. But they have one core concept in common. They launch workers that are short-lived. They perform a task and return a response. In the case of Airflow, this is commonly used for processing data at scale. A good example of this is tagging or clarifying images. Here we have multiple independent processes that can take pieces of data, process it, and return the result. One of the nice things about these tools is that we can create chains of dependencies where the results get passed from one process to another to use computing resources in the most effective way. This is heavily used in the AI industry and in the back-end processing. It's used in banking, it's used all over the place. And they use not just Airflow, they use all of the competing tools. And it's a field that I'm not really deeply versed in, but it's very interesting and a very important demonstration of scale. And here's the problem. This thing is nearly impossible to debug. This is so bad. Companies just let major bugs live in production and accept a pretty terrible error rate because they just can't debug this thing. They have logs, but with ephemeral processes, they lose the context very quickly. This is a perfect use case for continuous observability tools that can deliver more. So this is a basic Airflow web UI, where you can define a DAG, which stands for direct acyclic graph. It's the dependent processes. It's the dependent processes we discussed earlier. Here we can see a simple image classification algorithm, which we can activate via the web UI. So normally, I'm more comfortable with JetBrains IDEs, but for the purpose of demonstration, I'll switch to Visual Studio Code to show how things are looking there. So this is the Airflow demo that classifies images. The problem with Airflow is that we don't have an agent or a server on which our code is running. So an agent can come up, process, and then go away. By the time we get the snapshot into place, it's gone. This is where tags come in. Tags let us apply an action, such as a log or a snapshot, to a group of agents. That means that every agent that loads with a given tag will implicitly get the action of that tag. This functionality is very useful in regular servers too, in clusters and with multiple responsibilities. So tagging is something we use very heavily for large-scale deployments, not just in Airflow. It's a remarkably useful feature. By the way, notice that in VS Code, we need to add actions from the left pane. The UI is a bit different here, as VS Code doesn't expose as many extension points as JetBrains do at this point in time. Adding an action to a tag is pretty similar to adding it to an agent. We just add it, and it looks the same so far. So now that it's added, let's move to the agent's view and wait for an agent to come online and trigger the snapshot. By the way, notice that the UI for all of this is similar in spirit. It seems my booth decided that I don't need lights for some reason. It's motion sensors. So as I said, let's wait for the agent to come online and trigger the snapshot. But notice that the UI for all of this is, again, very similar to the one I showed you with IntelliJ with JetBrains. So we now have an agent that's running, and we got a notification that the snapshot was hit. Let's go into the Snapshots tab and click the snapshot. Unlike the JetBrains IDE, we need to open the snapshot manually, and it looks more like a VS Code breakpoint, which is good as it's native to the IDE. But the core idea, the UI, is of the snapshot with the stack variables, etc. That's the same as it was with the JetBrains IDEs. So in closing, I'd like to go over what we discussed here and a few things we didn't have time for. So Lightrun supports JVM languages like Java, Kotlin, Scala, etc. It supports JavaScript, TypeScript code, and Python, even complex stuff like Airflow. It doesn't yet support C#, as I see was asked in the discussion, but it's on the roadmap. I'm not up to date with the latest things on product, but it's very much something we'd like to offer in the relatively short term, because we're adding these things really quickly so far. And it's something that's very doable. We do want C# and .NET support as well. I'm not sure where they stand in terms of the order in which they will come out. We do support Windows, Linux, and Mac for most of our agents. So this is definitely something we will offer. So when we add actions, conditions run within a sandbox. So they don't take up CPU or crash the system. This all happens without networking, so something like a network hiccup won't crash the server. Security is especially crucial with solutions like this. One of the core concepts is that the server queries information, not the other way around, as you would see with solutions such as JDWP, etc. This means operations are atomic and the server can be hidden behind firewalls, even from the rest of the organization. PII reduction lets us define conditions that would obscure patterns in the logs. So if a user prints out a credit card number by mistake, you can define a rule that would block that. This way, bad data won't make it into your logs and won't expose you to liability. Blocklisting lets us block specific classes, methods, or files. This means you can block developers in your organization from debugging specific files. This means the developer won't be able to put a snapshot or a log in a place where a password might be available to steal user credentials, or stuff like that. This is hugely important in large organizations. One of the things I did in my tutorials that I wrote for Lightrun is show how to debug single sign-on, which is one of the most painful things to debug. I don't know if you've ever dealt with single sign-on. It's a nightmare. So I placed a snapshot in the native code for the single sign-on, in the Spring Boot code for native single sign-on, and there I was able to see credentials and information related to the sign-on process. And this made debugging that single sign-on really, really, really simple. The problem is, it's also a security problem because you don't want a developer, and remember 60% of break-ins into organizations are internal. So you don't want a random developer without privileges to be able to do that. So this is something you can toggle and use it when you need to set up the system, but disable it when it goes into actual production. So that way you can get the benefit of easy debugging and get the benefit of full security. So this is a really important bit. Besides the sandbox, I'd also like to mention that Lightrun is very efficient, and in our benchmarks, there's almost no runtime impact when it isn't used. It's, I think, the worst case scenario was, I think, 7%, if I remember correctly. It has very small impact still, even with multiple actions in place, because, again, they are very localized, and it's a different thing. We observe lower numbers than APMs, even when you add actions. And finally, Lightrun can be used from the cloud or using on-premise install. It works with any deployment you might have, whether cloud-based, container-based, on-premise, microservice, serverless, etc. So with that, I'd like to thank you for bearing with me. I hope you enjoyed the presentation. Again, please feel free to ask any questions as I answered the first one here. Please check out talktotheduck.dev, where I talk about debugging in depth, and also check out lightrun.com, which I think you guys will like a lot. And again, questions, I'm open for them in the Discord channel and by email and Twitter, as you can see here. So I'll take questions now. So what are the use cases of Lightrun with application insights? And how can we bring this as an input into our CI? Okay, great question. About the CI. CI is one of the use cases I didn't discuss, but it's actually one of the more interesting use cases. Because when a CI fails, again, this is kind of like Airflow. It's a process that runs in the background, and it fails, and you get sort of this huge log that you don't know what to do with, and you add more and more logging, and if there's a bug, especially a test bug, that only fails in the CI, which is something we've ran into. It's painful. You don't have the same sort of tools to debug that, and especially if something happens once in a blue moon. You've got a CI environment where something fails, so you can literally install the agent into the CI process. So when you run the tests, each of them runs with the agent, and this isn't something we're marketing so much because it's an edge use case that we need to get into, but it's a great one. And you get essentially you can place something very similar to breakpoints, snapshots, additional logs and things like that dynamically, and use the conditions and everything to get additional information on why a specific CI process is failing at a specific time. This has some challenges in terms of working with that, but it's a very powerful thing. The agent itself can be integrated during the development cycle and everything, but normally we see the agent mostly deployed in production and in staging. Some companies use it in staging as well, because it's very useful at that stage. And it lets you see things within the staging area that you normally would need to somehow connect the debugger, and especially in those environments which are sometimes already clustered to keep to be more consistent with the production, it's sometimes harder to debug them in any other way. So that's that.
Looks like we're at the end of the questions for now. I'm sure you'll keep answering them in the Discordy.
Sure.
Thing and with that, I'll just end the session. Cool. Thank you.
Great. Thank you. Have a nice day.